Hi, this is the Boffin, and I'm here to review the OpenEVSE that I built to charge my electric car with. Now, a lot of people are confused and think that this is the actual charger. The charger is actually located in the car. All this does is provide electricity to the car and tells the car a few things about how much electricity it's allowed to draw. In this particular case, I charge my car at 24 amps, even though this particular unit is rated all the way up to charging at 40 amps. Let's have a look inside. I've taken the screws out already. And inside you can see it's really quite simple. There's a big relay or contactor, there's some circuit boards, and there's the display boards. But let's first look at the ins and outs of this device. Has a J1772 cable which plugs into the side of the car. What came with the OpenEVSE kit is actually very nice quality. It's good rubberized cable. It's quite flexible, as you can see. But let's put that out of the way. Next, how does it get power into the actual unit? Well, in my case, I'm powering it by plugging it into the wall into a standard North American dryer outlet. Now, a standard North American dryer outlet is a NEMA 14-30. Somebody might be able to correct me on that, but I believe that's the part number. And it provides two phases, neutral and ground. We don't need the neutral in this case, but it provides us 30 amps. And that allows us to charge at 24 amps, which is 80% of the maximum. You're not allowed to draw more than 80% of a rated circuit continuously, and this would draw it for quite a period of time. Now, what you get with this kit is actually quite nice. It's a very solid ABS box. I've taken the 6 screws out so we can look inside. There's the 2-line display here, and a single push button which accesses all the menu options. It's quite clever actually how it works, very simple to use, and very solid pieces. They've used good quality pieces inside. The entire thing is built, and you can't really see it that well, maybe it's a bit shiny. It's got a big aluminum plate in the back that everything mounts onto. You can see the main power comes in over here, goes to one side of the contactor. The power going out goes on this side, the other side of the power contactor. In here are a couple of current sensing loops. One of them does the current sensing to detect whether there's a ground fault. The other one does the current sensing to tell you exactly how much power is being used. In the back here, nice big solid safety ground bus bar. This thing is probably rated a couple of 100 amps, but again, they've used very good quality components. This is the main OpenEVSE board. You can actually find the schematics and layout for this online, the OpenEVSE project. And this has most of the logic on it. Then mounted onto the back of the display at the front, the push button, the display. Let's get this a little bit closer in frame. Mounted on the back of the display, we have the Wi-Fi controller chip here. And we have the display board and a little secondary board which has an I/O expander and has the battery for battery backup. That allows us to hook this up via Wi-Fi. There's a nice little Wi-Fi page. You can look and see how much power you've drawn, what the temperatures are inside, and set some internal controls that actually aren't available through the menuing option. All in all, I think they've done a really good job. This is a good kit. It's got good solid components in it, and I think it provides very good value. What I purchased here was about $400 worth of parts. You can buy the various pieces separately, or you can buy them as a kit from OpenEVSE. I like the flexibility of this. Right now, I need to charge at 24 amps because that's all the power I have available in my garage. In the future, I might want to go up. That'll just involve rewiring this feed section of the device, different cable. Maybe I'll hardwire it in. Sort of depends on how it's going. Again, they used good solid quality. There's a good solid aluminum backing plate that everything is grounded to. And best of all, it's open source. So if you don't like something as part of the way it works, change it. There's nothing stopping you. On the cons, I think it would have been nice if they'd had slightly better instructions of how to put it together. I'm pretty good at this kind of stuff, and I had to go back and go, what? A couple of times. They do provide all of the parts to put this together without having to do any soldering. So all it is hooking up wires. I'm not convinced that's necessarily a good idea. There were a couple of places where I decided not to use the way they hook things up and to do it myself. One of which is I use slightly smaller gauge wire for the coil of the contactor. You might be able to see that back down in here. There's a red and black wire. However, the one that really sort of caught me out is right here. They had this joining of a little DC to DC converter which powers the Wi-Fi board, and the power off the Wi-Fi board is 2 sockets, and all you did was use 2 pins to join those wires together. That's goofy. That's probably not going to stay together. A little bit of shaking if you ever decide to pick this up and take it to somewhere else. So I just fixed that by joining the wires together right here. A little bit of heat shrink on them. And that's a much better solution. The other thing that's a little bit weird about this is the main board has a DC to DC converter on it. That's this big blue box, this Min-Max. It's good quality, off-the-shelf DC to DC converter. But it doesn't quite provide enough power to drive the whole thing. So deep next to it, and it's just taped to the back of the board, there's a little unit down here, which is a second DC to DC converter, which converts 12 volts off the Min-Max down to 5 to power the Huzzah, the Wi-Fi controller. Over here. Now these things aren't great for power consumption, but it strikes me that they would have been better off doing that just as one. In fact, I'm surprised that all of the electronics isn't on a single board, that they haven't reworked this board in here to contain an off-the-shelf 8266 board and the additional display logic in here and put it all together. However, I still think it provides a pretty great unit for not a lot of money and provides exactly the functionality I was looking for. Again, in summary, the pros, it's good value, it's very flexible, you can charge it a lot of different currents and even different voltages. It'll detect whether it's plugged into a single-ended or double-ended power, so it'll charge at 120 or 240. They used good quality parts to put the whole thing together, and it's open source. The cons, it's multiple electronics boards. They probably could have brought that down to one slightly larger board, would have been a little easier to put together. The instructions are not great. Sometimes you need to go back and have a second look at them and go, yeah, are these really the way it was supposed to go? And the third thing is, I really didn't like the way they did this goofy little connection between 2 sets of wires. That really needs to be soldered and some heat shrink over top of it. Do that. It was pretty simple. Anyway, enjoy the assembly. And that's it from the Boffin. Now what follows is a sped up version of the roughly 2 hours it took for me to put this together. I hope you enjoy.